Recording is rolling. It is Monday, September 16th. Bunch of guys just turned in your projectile quiz. Be grading those students I can. Yeah, guys, linear motion quiz. Just deal with that. I know it's by this point it's like a couple weeks past the due date. I have 3 different type classes. All my conceptual students have turned it in by this point, so I've got theirs back in their folders. Everybody, so AP and honors, I'm still missing a few quizzes. So if I don't have it in by the end of Wednesday, I just got to put in a 0 because all your classmates are waiting for those quizzes back. Also, I'm going to offer quiz corrections. I've been in this last few years. It's been a pretty good system. So here's how this works is when you get your quiz back, if you missed a graph question, just draw the correct graph on a separate piece of paper. If there's ever like a wordy conceptual type question, which AP doesn't get so much, but if you do and you miss that somehow, then just write out the correct sentence. Most of the questions are like algebra based. You set the equation and solve it. Now, guys, you guys, AP get like especially tough quizzes. I have to ask you guys for like really challenging questions. I know linear quiz. I think I threw a few scaling questions on there. Well, I have written up the solutions for my AP class. So the solutions where actually they're already on Google Classroom. I just haven't posted them yet. All I have to do is hit post and they'll show up, right? But I got to get them all in first. And so here, guys, double check focus. Make sure you're not missing that quiz because still got a few haven't turned in. Right? But once I get them all, or by Wednesday, I was like, okay, I got to get back to you guys at some point. Right? If you want to do corrections, there's an opportunity. Any question about corrections opportunity? Like that. Right. All right. Let's we got. All right. So guys, we're about to switch topics. I do have to go over progress check with you guys for kinematic motion. It's linear motion and projectiles, gradient. But starting tomorrow, we're going to be moving on to forces, Newton's laws of motion. And so here I'll do a quick preview with you guys, and then I want to show you guys what I'm doing in my other classes too, my conceptual honors, since they don't have the progress check. And so a little bit of preview stuff. We'll be going to the forces. Okay, I have here a bunch of spring scale. Now they're color coded. Each color is a different stiffness of spring. So like the green and the blue ones is not very stiff. You put a little tiny force on this, wow, 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 wow. There's almost no stiffness on spring. Okay, maybe it's good for like little tiny weights. Hey, you could hang a weight from it. It could tell you like the force reading. This was reading like half a Newton, like that. Which yeah, that looks about right. 50 grams, I think. Right. The brown ones are probably the most versatile. They're like, okay, medium stiffness. Feel medium stiffness. They could carry your large lab weights. Stretch this down. This is going to read, hey, 5 newtons. Ooh, 5 newtons. Hey, so 500 grams, pretty close to. Okay. And then the red, white, and gold ones. These are the really stiff. I think the stiffest one is this gold one. So, like, pull with a huge force. Takes a lot of force. A lot of force is really hard to stretch this because there's such a stiff spring in it. Hey, do you guys think that's a physical property? How stiff a spring is? Might be called spring constant or spring stiffness. I think both those terms. Right, so tomorrow, and here I just want to flash this for you real fast. You have a night to sleep on this, think about this. Is I'm gonna have you guys do these 10 mini labs where you do a bunch of different things. You like hang weights, or you take 2 spring scales. What if I hold 2 spring scales and hold a weight and like shift the weight around? Okay, can you go into 2 dimensions? What if you like spread out, make like a Y shape, and make the Y wider, make it closer to a T? What do you think is going to happen to the force readings in each of these scales? The bottom one, the top ones. Suppose you have the same lab weight over and over. Okay. Oh, hey, what about like this vertical chain gang going on? Okay? And there's a variation on this. It's like if you turn it's like a choo-choo train, something like pull on whole train. Okay? What if you slip another one in the middle? Ooh, like I got 2 spring scales here. Got weight, spring scale, weight, 2 spring scales, weight, spring scale. What the force readings are going to be on each of those? Hey, what about motion? What if you accelerate this up or down? You guys been in an elevator? Right, when the elevator starts to move, go, whoa, feel a little bit weird. And when it comes to stop, whoa. Right? Here's a variation on that with the string. Hey, we'll do a little mini friction going on. What if you drag it across the surface? We'll do a more extensive version of that later too. All right, so yeah, we got these 10 mini labs, spring scales. I want you guys to start to think away around. What do forces look like? Right, so if you hang weights, how do forces distribute? What changes angles? What put it in motion? Kind of thing. Okay, and then there is okay. So talk about flipping animations a little bit. This is what my other classes are doing. Oh, back up. Sorry, I got one more thing on spring scales. Almost forgot this. Got a poster for us ready to go. So here's called Hooke's law. Remember I was showing you guys different stiffnesses? What you'll notice is that the scale rating is linear. Oh, look, what do you guys think the unit capital N stands for?
Newtons.
Newtons. Aha, newtons. Now the brown ones go up to 10 newtons. So, and you guys see how it's scaled linearly? 2, 4, 6, 8, 10. Okay, so if I put them like, if I put some amount of force, maybe it's like 2 newtons. If I double the force, ooh, now I'm to 4 newtons. If I double that force, ooh, right? You guys see by doubling the force, I double the amount that it stretches. Huh? Okay, that's why it's scaled like that. Huh? All right, so that's called Hooke's law. Hooke's law. Here's the formula for that. F equals kx. So the more force I put on, the more it stretches x. And then k, what do you guys think k stands for in this context? Ah, constant, the spring constant. Spring constant. Sometimes you hear spring stiffness also, right? Okay, and that would be a linear relationship. Okay. Some textbooks throw a negative sign there, so like a restoring force, like if I pull it down, the spring pulls back the other way. I don't know. And then yeah, the accumulated area under the curve also represents something. Well, it's like how much energy is stored in it, but we won't talk about that for a few weeks. All right. Let's look real quick at some animation. So my other classes, I'm having them apply all this motion stuff to animations. Can they make an animation with this? So I'll show you guys some examples. You guys ever made a flip hook? Flip hook. So we'd be doing. So I got a couple of projectiles going on. Projectiles. Whoa. Also got these some from some of these are getting a few years old now. Ooh, projectile. Oh, I forgot he missed in his own animation. All right. We got oh, yep, that would be the end, wouldn't it? All right, what else? It's this guy. Oh, well, okay, that escalated quickly. So we got okay, I guess that's how that concludes. Hey, all right. What else? It's got hey, how about guy with bow? That can't go wrong, right? You're boing. Hey, all right. Like, oh, it zooms in. Yeah, pretty good, pretty good. All right, so here, guys, there is a blank one on your desk. So, this won't be an assignment, but if you want to pick it up for fun, you can. There's some heavy duty scissors. Here's how you make this. I'll do this much with you guys. You guys see part of it stapled? Part of it stapled. Gotta make this first. So I'm gonna roll once, roll twice. Okay, now if you got that, then hang tight. If you missed that, I'm gonna rewind a little bit. So I'm gonna roll once, roll twice. I kind of press this out. Okay, you guys see I rolled it like that. Okay, then take the big old scissors and cut off about maybe almost a centimeter at the end. All right, look like that. Like I said. All right, and then when you unroll, pull it out. It makes a really nice flip foot. All right. So if you guys want to keep that, you can. Made one for every student, and then my other classes. That's their assignment today is to try that. All right. So you guys good so far? You guys good? All right. You guys ready to go over the answers to the progress check? All right. Progress check. Answers time.